In this video, we're going to start talking about exponents, and in the rest of the unit, we're going to then translate that into radicals. So first, we're just going to review the exponent laws, which we've already discussed back in the first unit of this course. And so if we're multiplying two things with the same base, a and a, then we add the exponents, so m plus n. Divide two things with the same base, we subtract the exponents. If we have something to a power and then raised to another power, well, we multiply those exponents. If we have a multiplication, and it's very important that this piece in here be a multiplication or a division, and we have an exponent outside of those brackets, then we get the exponent with each term. This works also for division, but not for subtraction or addition. Anything to the power of 0, if we move it up, is 1. Provided that anything, so a in this case, is not equal to 0. 0 to 0 is a different issue altogether. And finally, if you have a negative exponent, you can write it in the denominator, or if the negative exponent is in the denominator, you can move it to the numerator. Provided again that a is not 0, because we wouldn't want to have division by 0. A final note, when you start simplifying these expressions, your final answer should only have positive exponents. So a simplified result should never have a negative exponent. You'll use rule 6 to get rid of the negative exponent. So we're going to go ahead and do some examples, just using these rules to make sure you're comfortable with them. So a here, we have a to the 5 and a times a to the minus 3. That's 5 plus minus 3, which is a squared. Here we have a to the 3 and a to the minus 5. Again, we add those together, we get a to the minus 2, but we can't leave a negative exponent, so we have to write it as a, or 1 over a squared. Then c, well, we're multiplying two things with the same base, so we add these exponents first. So that's going to give us 10 to the minus 1, 3 plus minus 4, and that's still squared. Now we have an exponent and an exponent, so we're going to multiply those together. That gives us 10 to the minus 2. But we can't leave minus 2 because it's negative, so we have to write it as 1 over 10 squared, or 1 over 100. Either way, it's the same result. So we have some more examples of using these rules. These are quick examples just to make sure you're understanding. Make sure, maybe now pause the video and go do these. Come back and make sure you got them right. So here we have a squared and a, so we're going to end up with a to the 2. If there's no exponent written, that means 1, so that's going to be 2 minus 1 for the exponent. B, we have 3 minus 7. And c to the 0, well, 0 tells us that that's 1, provided c wasn't 0. And now we can simplify that. That's a to the 1, b to the minus 4. But we can't leave minus 4, so we get a over b to the 4. Now most of you at this point will be able to go straight from there to the result, and that's fine. I'm just showing you all the steps in the middle here. If we bring in the exponent, we start this next example, we get x to the minus 6, y to the 3. Minus 6 we can't leave because it's negative, so we have to write it on bottom to make it positive. This one we'll do a little differently. Here we distributed in the 3 with each exponent first. This one we're actually going to take care of the negative first. So the negative tells me we have to take the pieces on bottom top and top down bottom, kind of like a reciprocal. So we're going to start by saying, well, this has to be the same as a squared over 4, but now all to the power of positive 3. Now we can bring in the exponent. We get a to the 6 over 4 to the 3. And we can simplify 4 to the 3 if we want, or we can just leave it like that. So we have a couple more, and then a note here at the end. G, first we're going to work out each part. So we're going to get x to the 4 and y squared, and that's by bringing the 2 in here. Again, x squared and y are multiplied. That's why we can multiply the exponents by 2. And then because these are divided, we can do the same. So we're going to get 2 to the minus 2 over x to the minus 2. And you'll notice here we did this one a little differently. Instead of taking the reciprocal first, this time we just brought in the minus 2 first. You can use these rules in any order, so you can approach it any way you want. Now we can put all the pieces together, so we're multiplying these, so we end up with x to the 4 y squared multiplied by, well, this is a negative exponent, so it can come up. That's x squared. And this is negative, so this comes down. This becomes 2 squared. X and x are the same base, so we can add those exponents and end up with x to the 6 y squared over 4, or over 2 squared, whichever you prefer. The final example has a plus sign. And be very careful of the plus sign, because that's something that students tend to get wrong quite often. Look at the previous examples, they all had multiplication division, nothing with addition or subtraction. Addition and subtraction change what you're able to do here. So we have a negative exponent, that means put it on the bottom, but we have to put everything on the bottom because it all has the negative exponent. So what we get is 2a plus b to the minus 1 squared in the denominator. We're actually not allowed to bring the 2 in here. Think back to what we've done the previous unit with expanding brackets and having things squared. We don't just square both parts with the plus, so we just leave that alone. We can do something with the b to the minus 1. Well, the minus 1 goes just with the b, so what we can do is say, well, that has to be 2a plus 1 over b. Only the b has minus 1, so only the b goes down, squared. Now we just finished common denominator, so you should realize that that gives you 2ab plus 1 all over b, all squared. And if we keep simplifying, that gives us b squared. We take that all the way to the top, over 2ab plus 1 squared. Now that's a little harder, and that's because of the plus. You have to be much more careful in your algebraic manipulations, but that's a very common mistake, so pay close attention here. Often students will mistake this squared and bring it in with each part, but because of the plus, you're not allowed to do that. Okay? As soon as you see a plus or minus, you should take a second and evaluate the question very carefully because it changes what you can do. And also, negative exponents can only be moved directly to the numerator or denominator when they're being multiplied or divided, not if we're adding or subtracting. So for example, 4 over a b to the minus 1, the b can come up because everything is multiplied or divided. In the next example, this b here is added to something else. It's a term, not a factor, if you can keep those ideas in your head. So we can't just bring that up directly. We have to write it as 1 over b. And then we continue with the same sort of simplification as we just did with question H above. So we'll end that video there. That's a quick summary of the exponent rules and working with them. Hopefully you got those questions right. We have done this stuff before, so it shouldn't be a stretch to be able to work these out already. In the next video, we'll start talking about fractional exponents, so we can begin to move towards radicals. If you have any questions, make sure you get some help, and we'll see you in the next lesson.